Hello everyone, in this video we are going to talk about Chapter 6, Lesson 5, Special Parallelograms, Rhombi and Squares. So first we are going to talk about properties of rhombi and squares, and then in the second part of the lesson we are going to prove if a quadrilateral is a rhombus, square, rectangle, and a parallelogram. Let's get started. Here we have a rhombus. We know this is a rhombus because all four sides are congruent. This is the first sign of having a rhombus. If you see a four-sided figure that has all equal sides in length, that means it's a rhombus. Another important property of a rhombus is the diagonals are perpendicular to each other, which means one of the angles are going to be 90 degrees. And then all these four angles are going to be 90 degrees. So the diagonals are perpendicular is the first important property other than having all equal sides. The next property is each diagonal bisects a pair of opposite angles. For instance, RO is one of the diagonals. It cuts two angles in half. This one is the first one that is cut in half by the diagonal. And then these two angles are equal to each other because they are cut in half by this segment. Same thing applies for this segment and the two angle pairs right here. They're all equal. So now let's talk about squares. Squares have all four sides equal in length, and the diagonals are perpendicular right here. The diagonals are perpendicular. These four segments are equal to each other. We didn't mention that, but same thing applies to a rhombus. MB is equal to RB is equal to BH is equal to BO. Same thing applies for this again. It applies to this. The segments are equal. The parts of the diagonals are equal in length. And all of these angles, the whole thing is 90 degrees, but the diagonals cut the angles in half, which means this part of angle C is 45 degrees, this part of angle C is 45 degrees. Same thing applies to all of these angles. They are cut in half, 45. So now let's have an example. So here it says in a rhombus ABCD, we know this figure is a rhombus. That means without reading the rest of the question, I want to mention that all of these sides are the same. And the diagonals are perpendicular. And diagonals cut each other in half, and they cut the angles in half. So now let's see what the question is about. Angle BAC is 32 degrees right here. The angle is 32 degrees. This one right here. So find the measure of each numbered angle. Let me figure out all of the angles. So if this angle is 32 degrees, since AC is one of the diagonals, it cuts angle A in half. It seems like one of the halves of angle A is 32 degrees, so the other half is going to be the same. This one is 32 as well. Now, as I mentioned, right here, we have a right angle. It's 90 degrees. Just like that one, angle 4 is going to be 90 degrees. Angle 4 is equal to 90. Its measure is 90. So now, right here, we have a triangle. One angle of that is 90 degrees. Triangle is a right triangle. So two angles is given. The given angles are 90 and 32. Angle A and angle 4. These two angles, if we add them and subtract them from 180, we can find the measure of the missing angle, 58 degrees. The missing angle of the triangle is angle 1. So the measure of angle 1 is 58. Now that I know angle 1 is 58, remember, just like these two angles are equal to each other, these two are going to be the same, angle 1 and angle 2. So angle 2 is 58 degrees. So measure of angle 2 is 58. Now, if you look at this triangle on the right side and on the left side, the angles are 90, 32, and 58 for this angle. For this one, the angles are 90, 58, so the missing one should be 32. That's what's left from 180 degrees. Now, we have the same pattern. AC is a diagonal. That means it cuts angle A and angle C in half. So it's not supposed to be 38, it's supposed to be 32, by the way. Now, because of the same reason, angle 3 is going to be the same. So measure of angle 3 is going to be 38. I keep saying 38, it's supposed to be 32, sorry about that. And just like these two are equal to these two, 58 degrees are going to be the same as these two angles. Just in case you wonder what those angles are, they're going to be 58 degrees and 58 degrees. Now, here we have another question. Quadrilateral ABCD is a rhombus. So the sides are the same, the diagonals are perpendicular, and they cut each other in half. And they also cut the angles in half. These are the properties that we know. Find each value or measure. Now, two segments are given. AE is given 3x minus 1. Right here, AE is 3x minus 1. And AC is 16. Let's see what AC is. AC is this whole thing. It is 16. Now, if AE is 3x minus 1, since the diagonals cut each other in half, EC is going to be the same as AE. So now we know AE is equal to EC. So let's plug in 3x minus 1 for EC. Now, if you look at these two segments together, there's 2 of 3x minus 1s. 3x minus 1 plus 3x minus 1, or just multiply it by 2, should be equal to the whole length of AC, which is given. We know what AC is. It is 16. So it should be equal to 16. If we solve this equation by combining like terms, we have 6x minus 1 plus negative 1 is negative 2 equals 16. So add 2 on each side. 6x is equal to 18. Divide by 6, so we get x equals 3. The question was about finding x. We did so. We are done with that one. Let's move on to this. We have the same figure now. In this question, it says measure of angle CDB. First, let's figure out the angle. Angle CDB is right here. Is 6y. So let's write 6y for the angle. And angle ACB is 2y plus 10. Angle ACB is right here. It is 2y plus 10. Right, this gap is equal to 2y plus 10. So now the angles is this one, the other one is that one. And remember, in a rhombus, the opposite sides are parallel. So these two sides, BC and AD, must be parallel. Now we have two parallel sides, these two, and between them we have these two angles, right here and right there. And also these two sides are parallel. Now the highlighted angles are called alternate interior angles. These are called alternate interior angles, and their measures are equal if the sides are parallel. So 2y plus 10 is equal to 6y. If we subtract 2y on each side, 10 equals 4y. If we divide it by 4, we get y equals 2.5. Here is the last example. In this part, we are going to determine whether a quadrilateral is a rectangle, rhombus, or a square. So we have a couple of statements that explains how to do so. So the first one says if the diagonals of a parallelogram are perpendicular, then it's a rhombus. So if the diagonals are perpendicular, then it's a rhombus. This is one of the ways to prove that if a quadrilateral is a rhombus. That means the diagonals must have negative reciprocal slopes. Because if two segments are perpendicular, that's what happens. So the next one, if one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So using coordinate proofs, we cannot show this one, so I'm just going to skip this one and I'm not going to explain that. If one pair of consecutive sides of a parallelogram are congruent, then it's a rhombus. So this one tells us basically all the sides are equal if one pair of consecutive sides of a parallelogram are congruent, we're going to choose two sides and then see if their measures are the same. Then we are going to say it is a rhombus. And if a quadrilateral is both a rectangle and a rhombus, then it's called square. So we know what we need for the rectangle. The diagonals must be equal in length. So the distance between the endpoints of the diagonals must be the same for us to say it's a rectangle. And here are the statements that we will see if we have a rhombus. Now let's go over the example. Determine whether parallelogram ABCD with vertices ABCD is a rhombus, rectangle, or a square. So here's a key information. We don't need to prove that if this is a parallelogram or not because it is given already. Now I'm just going to draw out a random quadrilateral that looks like a rhombus. So I'm going to start labeling the points. A, -3, -3. B is 1 and 1. C is 5, -3. And D is 1, -7. Now, let's see what we need to do if we need to use the slope or distance. First, I'm going to just give you a reminder, guys. Rectangles means diagonals are congruent. Rhombus means diagonals are perpendicular. So only working with the diagonals are going to be enough for us to say that this is a rectangle or a rhombus because we already know the figure is a parallelogram. So now let's get to work and then see what is the slope of AC. So the slope of AC, we subtract the y values and get 0. -3 minus -3 is 0. And then we subtract the x values. -3 minus 5 is -8. Now we need to find the slope of dB. Slope of dB is equal to we subtract the y values first. 1 minus -7 is 8, and 1 minus 1 is 0. So if we look at the slopes carefully, this means the difference between the y values of the segment is the same. So if this is the coordinate plane right here, y values of the segment means it's going to be a horizontal line. And this one right here means the x values, the numbers in the bottom means they are the x values, and there's no difference between the x values. That's what this says. If the x values are the same, they look like this. Because on this segment, all of the x values are equal to whatever that number is. Now, this is a vertical line, and this is a horizontal line. Zero slope means horizontal line. Undefined slope means it's a vertical line. So you might want to keep that in mind. And just like the coordinate plane, vertical lines and horizontal lines are perpendicular to each other. So this means the diagonals are perpendicular. The diagonals are AC and DB or BD. So since the diagonals are perpendicular, this figure is a rhombus. Diagonals are perpendicular. We say since AC is perpendicular to BD, then ABCD is a rhombus. So this is how we show if the figure is a rhombus. For the rectangle part, we need to do the distance for segment AC and for segment DB. If their distances are the same, just like what we said here, if the distances are the same of the diagonals, then we say it's a rectangle. Now the distance of AC is, find the difference between -3 and 5. The difference between these two numbers is 8. We square that number, and then the difference between these two numbers is 0 because the numbers are the same. So 8 squared is 64, but we gotta do radical 64, which is 8. Now let's see the difference between the x coordinates of D and B. The numbers are the same, that means there's no difference. So 0 squared plus the difference between y coordinates of these 2 points. From -7 to +1, we need to go 8 units to the right. So the difference is 8, which is radical 64, which is equal to 8. Now this means the diagonals are congruent. AC is equal to DB in length. So since the diagonals are the same, that means ABCD is a rectangle. So in conclusion, since it is both a rectangle and a rhombus, it's called a square. So let's go over what we did. We just draw a random quadrilateral and labeled the points by following this pattern A, B, C, and D. And then we worked on the diagonals. We found their slopes and the distances. If they have the same distance, if the diagonals have the same distance, that means it's a rectangle. If the diagonals are perpendicular, which means if their slopes are negative reciprocals of one another, the figure is called a rhombus. If it is a rectangle and the rhombus at the same time, then it becomes automatically a square. So that's all for this lesson, guys. Thanks for watching. Please comment below if you have any question.